Hey all beautiful people out there, what's up? This is Avjit Nair aka the Code Man. Welcome to the Generics in Java Part 1 video tutorial. In this video tutorial, which will be of two parts, we're gonna dive into the usage of generics in Java. So before we jump into the generics or why are used by Java programmers around the world, we need to know about the collection framework in Java, which eventually led to the creation of generics in Java. So the collection framework in Java is a common interface for uh, using several data structures such as linked list, array list, vector hash table in Java. We do have linear data structures such as arrays where we can store data, but these arrays are not dynamic. They cannot be expanded. They have a fixed length. So we need to use data structures such as array lists, which are dynamic in nature. But if you don't have a common interface for these data structures, then it's a little bit tedious to use these data structures because all of them have different methods of input and output. For example, the stack data structure, to input data into the stack, we need to call the method uh, push. The push method, we have to call the push method in stack to insert data into the stack. Whereas in array list, we use the method dot add. So with the collection framework, we have an interface, common interface, where there are methods which are common to all these data structures, and hence it becomes easy to program on these. And also, it's a good practice to program on an interface rather than on the actual implementation. So let me show you the hierarchy of the collection interface in Java. So collection means a group or container of objects, and framework refers to an interface that has methods which are common, which can be used for all the collections, for all the data structures in the collection. And interface forces you to adopt a good design practice in programming. So here is our collection framework, which has sub interfaces list, queue, set, and they in themselves have array list, linked list, vector, stack. And the super type interface of collection is iterable. This iterable method has an abstract method iterate, which iterates over the over your collection, such as list, vector, or hash maps, and displays items inside these data structures. And so as you can see, the blue ones are interfaces and the green ones are classes. And the subtypes implement the supertypes, like list implements the collection interface, and collection in itself implements the iterable interface. And let me show you the Oracle Java documentation of collection framework. So here's our outline of the collections framework, and let me click on collection. So as you can see, there's this interface collection type parameters. We will discuss about type parameters in the second part of the tutorial. That's where the generics come into play. And you can see the number of methods that are present in the collection interface, like add to add elements into the different data structures present inside the collection framework, and there's this iterator to iterate over the elements, and size, which returns the number of elements present in the data structure inside the collection framework. So let's type out a piece of code using the collection framework. So all the collection framework is inside the java.util package. So we need to import java.util.asterisk. This imports all the classes that is present in java.util package. And now let's define class, let's call it A, for example, and our main method, that is called static void, void main string arguments. Now let's define an array list data structure. So as you can see in this diagram, array list comes under list. So we be making uh, the object instance of array list and storing it in the list variable. So list L equals to new array list. So what essentially happens here is that the compiler implicitly upcasts the array list data structure to the list type. Let me write it out in comment. Compiler implicitly implicitly upcasts the array list type to the list type. And list has a method called add to add entities into the list data structure. So let me give some value. L dot add sample apple, and L dot add orange. Let's give one more. So this time it's gonna be mango. L dot add mango. Now the list class inside the list interface stores a collection of types of stores a collection of object type. An object is a super type of all the classes in Java. So whatever entity of any type, that is like string or integer or float, you pass into the list data structure, it will the compiler will implicitly upcast that to the object data type, because object is the super type of all the types in Java, all the data types in Java. For example, string, integer, float, all are the subtypes of the object type or object class in Java. So let me comment it out. Compiler upcasts the string, so the string data type to the object type. And this happens for each of these statements. And this part is done by the compiler itself, because list stores entities of the type object. So it converts all the data types to the object data type. Now it's time to print out the list. So that will be a system.out.println and L. This will give output in the form of a square bracket, where if the apple, then orange, and mango. Now it's time to define the iterator in our program, so that it iterates over the list of list collection and displays data on new line. So in order to define an iterator, we type out like this: iterator I, some variable name, equals to the data structure to which we through which we need to iterate, that is list here. So L dot iterator iterator method. And now we will use a while loop, while I, and we will use a method called hasNext, which checks if the list contains more elements, and if the list contains more elements, then it will return the next element that is present in the list. So while I dot has next, and now the ob uh, the objects that are stored in the list are of the string data type. So we need to store that into another string object. So the string a equals to. Now remember that during in this part of the code, the compiler implicitly upcasts the string data type to the object type. So we need to here again downcast it back to the string data type to store it in the string object. So if we do that like this, string and I dot next. Next is also a method available in the list interface that uh, not in the list interface actually, in the iterator interface that returns the next element present in the list. So string a equals string I dot next, and then we'll be printing this out on separate lines. String print ln and a here. So let's execute it, and here it is. Apple, orange, mango as the expected output at line number 10, and we have apple, orange, mango printed out on separate lines using the iterator. So till this it's all good and fine, but after this there's one problem in this code because of which Java programmers around the world decided to use the generic concept in Java, and the problem is type safety, and we'll be discussing more about this in the second part. But let me give you give you a hint about what problem caused the creation of generics in Java. Here, instead of passing a string object, if I had passed an integer object, there would have been no error in these lines of code because the compiler will upcast any type to the object data type. But when it comes to this part of the code where the programmer has to explicitly downcast the data type, the object data type back to the data type that has been specified previously, uh, this this incompatibility that you are downcasting an integer object to a string type. This is where problems come in, and this is what we're gonna explore in the next part, where we'll be using generics to ensure type safety in our program, so that we don't get runtime errors. All the errors will occur in the compile time itself, so that we can handle our program in a better way. So stay tuned for my next video tutorial, and if you like this video tutorial, give it a thumbs up and also hit the subscribe button. So peace.